Hi, I'm Paul Glasziou. I'm a general practice researcher at Bond University and interested in the better use of research, and I want to talk to you today about reading the numbers. Okay, let's spend some time looking at reading the numbers. As an example, let's first of all look at this headline from the Specialty Pharmacy Times about the ASCEND trial, which says aspirin prevents serious vascular events in diabetes. An interesting headline, but how much does it prevent? What's the size of the effect, and are there any downsides? What's the certainty about this? If we read the article, we wouldn't get any of those questions answered. So let's instead go to the article. Okay, here's the full article from the New England Journal, and I don't want you to read every word of this. Let's just have a look though down at the highlighted section at the bottom. And what it says is that there were 15,000 participants roughly randomized. This was a placebo-controlled trial, and that was a follow-up of 7.4 years. All of us tells us that this is probably pretty good information, which we didn't get from the previous headline. But I want to focus on the numbers, and these numbers are about the serious vascular events. And the highlighted numbers that you can see there are the ones that I want to focus on, but they all look like gobbledygook and are a bit hard to read, I know. So let's have a look at what they are. Let's pull them to the side and see that for the serious vascular events there were 9.6 in the placebo group and 8.5% in the aspirin group. Okay, they're the basic numbers at 7.4 years, and we can compare them in two different ways. One is to take a ratio, and if we took a ratio, that would be 0.88. 8.5 divided by 9.6 is 0.88. Now, if the numbers had been equal in the two groups, that ratio would have been 1. So here it's less than 1, 0.88, or a 12% relative reduction. If we'd taken a difference, that would have been 9.6 minus 8.5, and that would have been 1.1%, which we call an absolute risk reduction or rate difference of 1%. So notice that there are two different ways that we can express that difference between the two numbers. One is a 12% relative reduction, and the other is a 1% absolute reduction. So next time you read a number that says something was reduced by X%, ask yourself, was that a relative reduction or an absolute reduction? And usually you can't tell in the newspaper articles or doctor magazine articles that you read. Okay, so even though it was a large trial, there was some uncertainty about those numbers. So let's have a look at the two different ways that we can express that uncertainty about that reduction in serious vascular events. So let's go back to and highlight the numbers from the abstract, and we can see them here, that the rate ratio was 0.88. And there's this thing called a confidence interval going from 0.79 to 0.97. So what's that? It's the upper and lower bound of the likely true value. And you'll notice that both of those numbers are less than 1. That tends to suggest that the real effect is still beneficial. It could be as low as 0.79 or as high as 0.97, but it's still not 1. The other way we could have expressed the uncertainty is a so-called p-value. The p-value is the probability of getting these results by chance if there was no real effect. And we tend to like small p-values because we like a low chance that this is not a real effect. So here it's 0.01. That is, there's only a 1% chance that this could have occurred if the two treatments were actually equal, and this was just a random event, a random result. Later on in the article, they express those results visually. So here's a graphic of it I know it's very complicated, but let's just focus in on the highlighted line, which are the numbers that we've been looking at. And note also that if you look right down the bottom, that to the left aspirin is better and to the right placebo is better. And in the middle, this is a rate ratio, so the line of 1 is where the rates would be equal. So notice that, and we can read that for all of the events that you might be interested in. But for the moment, let's just blur out those others and focus in on the serious vascular events. So here's the same numbers again, but this time presented as a diamond and showing that both confidence limits and our estimate are to the left, that is that aspirin is better, and at no stage does it cross the line of 1. So that's a very important thing to note, and that corresponds to that p-value being less than 0.05, in this case 0.01. While we're here, let's just also note at the bottom where it says any major bleeding that is placebo being better. So there's actually an increase in any major bleeding. That means that, and that's a statistically significant difference, 0.003, and you'll again notice that the confidence interval this time doesn't cross 1 either, but on the other side. Okay, so we have a small beneficial effect, and we have some harms of the major bleeding as well, and need to weigh those up. And that's actually quite a difficult decision. So just going through those again, the 95% confidence limit here gives us the upper and lower bound on the likely true value, and the p-value is the probability of getting these results by chance if there's no real effect. Okay, and so they're the two different ways of expressing uncertainty. So now if we come back to our headline, I think we'd cross out the one that was in the Specialty Pharmacy Times and look at this other one, which I think is a much better expression of the results. Bleeds and benefit with aspirin balanced in diabetes patients. Yes, we have certain benefits, but we also have certain harms as well, and both of them small but being in opposite directions. Okay, so that's it for reading the numbers. Good luck with reading your own.